Okay, so section 6.2, applications of the normal distribution. So right away, we just get into an example. Like I said, we really set the stage last time, and now we're just going to apply it. So example 1 says, an American household generates an average of 28 pounds per month of newspaper for garbage. Assume the standard deviation is 2 pounds. Assume the amount of newspaper garbage is normally distributed. And then if a household is selected at random, find the probability of generating between 27 and 31 pounds a month. So there's some things in here that I just want to highlight. Let's see how my highlighter works in black background. Oh my gosh, that's so weird. It only highlights the text, but I kind of like it. Okay, so so we have an average of 28 pounds per month. So right away, that is our mean. That's too big. Okay. Okay, so right away, that's our mean. And then it says our standard deviation is 2 pounds. Awesome. And then it says assume the amount of newspaper garbage is normally distributed. Okay, cool. All important things that we need. So then we want to talk about if a household is selected at random, what's the probability that it generates between 27 and 31 pounds a month? So we're going to go through step by step on how to do this, and then we'll just do some more examples after. So your notes say, how can we solve this problem when our tables only go up to z equals 3.49? Notice that none of these values are z-scores, so none of the stuff that we're given is a mean of 0 and a standard deviation of 1. Obviously, 28 is a lot higher of a mean than 0, and a standard deviation of 2 is bigger than a standard deviation of 1. So we have this problem that like our tables don't go up this high, so we need to convert the information we're given into like a standard normal distribution so that we can use this table that we have. So, it says we need to convert this normal distribution into a standard normal distribution. And this is when we use that thing called a z-score, and that's just so we can use our tables. So first of all, part A just says, what are the x values that we are interested in? So that values that we're interested in are the ones that we're asking, what's the probability of something falling between these values? So our question asks, if we select one at random, what's the probability that it falls between 27 and 31 pounds? So those are going to be the x values that we're interested in. So we are interested in 27 and 31. Okay, so now part B says to convert these into z-scores. This was something that we practiced last class, but let's just refresh our memories here on how we do this. So we're going to do the first one, which is 27. So I'm going to call this z1. Last time I just said z equals da-da-da, and I converted it, but since we're doing two values here, I'm just going to call one z1 and one z2. So let's do 27 first. So I'm going to say that's my first z. And remember how we find these? We take our x value, so in this case it's 27, and we subtract the mean from it. So we were told our mean is 28. And then we divide by the standard deviation, which is 2. 27 minus 28 is -1. So you have -1 over 2, which is -1/2. Okay, let's do our next one. So I'm going to call this Z2. So I take my x value, which in this case is 31, and I subtract the mean from it, which is 28. And I just divide by the standard deviation. 31 minus 28 is going to give us 3. So I end up with 3/2, which is equal to 1.5. Okay, so now I've converted my 27 and my 31 into z-scores, which treat our new distribution like a standard normal. So now I've made this a lot easier to use those tables to find probabilities. All right, so part C says, now draw a standard normal distribution with mu equals 0, so the mean is 0 and the standard deviation is 1, and locate the z values you just calculated. So it says, this should now look like a familiar problem. So we did this a little bit in last class where I would draw the diagram and then I would shade in the area we were trying to find. So I'm going to do that again. So we just draw our bell curve, and in the center we have 0 because our mean is 0. And the values that we have, so those z-scores, we have 1.5, and then we have negative 0.5. And I'm just going to draw that. And we are looking for the area sandwiched in between these two, so we're looking for this area. We're looking for the area from negative 0.5 to 1.5. So we shaded the region, and now we just need to determine the probability. So there's just a little note written here that says, notice that the probability that x is between 27 and 31 is the same as the probability that z is between negative 1/2 and 1.5. All it's saying is that notice that the probability that we're asked for at the beginning about x being between 27 and 31 is the same as the probability of z falling between our z-scores that we calculated. Just saying, hey, notice that we can calculate this by converting those numbers into z-scores, and it's the same thing. So nothing new so far. This was all stuff that we did last class period. This was now really just doing a word problem with it, but the process is ultimately the same. So if you remember what we did last time, now we would look for our table values at these z-scores. So we need to find the table value for z1, and we also need, let me write what those are. Sorry. So we want the table value for z1, which is negative 0.5. And then we also want the table value for z2, which is 1.5. Okay, and to do this, we just need to go to those handy tables that I gave you guys last time and showed you how to use them. So let's do that. I'm going to pull that up. Okay, let's do negative 0.5 first. Let me just zoom in a little bit here. So I want negative 0.5. So I'm going to go, sorry. So I'm going to go down my left-hand column and find negative 0.5, which is right here. And then since I just have 0.5, I just want for the top row, I want 0 because there's no number after 0.5. We don't have like 0.52 or something. We just have 0.50 essentially. So I'm going to see where these meet, and they meet up at 0.3085. All right, and then I'm going to do the same for my other z-score, which was 1.5. So if we find 1.5 on the left here, that's right there. And since we don't have anything after the 0.5, we just want where it intersects the 0. And that's at 0.9332. Okay, so let's come back and write those numbers down. Okay, so for negative 0.5, we got 0.3085. And then for 1.5, we had a value of 0.9332. And then remember, like we did last class period, we take the table value associated with the z-score that is furthest right on the diagram, and we subtract the other table value for the other z-score from it. So we just take 0.9332, and we subtract from it 0.3085. We pull out our calculators. That gives us an answer of 0.6247. And that is the probability. So that's it. It's really the same thing we did last class. Now you just have an actual word problem associated with it. So now you kind of see how to apply it and how to pull things out of that word problem. And then we're really just going to do, I think, about 2 more examples and then one more little tidbit of information about normality. So not too much today. But are there any questions on this first example before I continue on to the next one? Okay, so our next one, example number 2, says college women's heights are normally distributed with a mean of 65 and a standard deviation of 2.7. What is the probability that a randomly selected college woman is 62 inches or shorter? So let's go ahead and just highlight what information we're given. So we know the mean is 65, standard deviation is 2.7, and we want the probability that a randomly selected woman is 62 inches or shorter. All right, so the value that we're interested in is 62. So we'll need to go ahead and convert that to a z-score. And then follow the same process that I did on example 1. So since we did a lot of this last class period, I'm actually going to let you guys try this one like I usually do. So go ahead and try this on your own all the way through. And then private chat me your answers when you get them, and we will go over it together. So go ahead and give this one a shot on your own. I didn't say this, but you just need to do the first one, not the second one that asks for the probability that a woman is between 63 and 69 inches tall. So just work on the first one for now. Okay, so I've got a few answers by now, so let's go ahead and go over how to do this as a group. So number two, the first one wants to know the probability that a randomly selected woman is 62 inches or shorter. So first of all, let's go ahead and convert this to a z-score. So we have z is equal to, and we're interested in 62, so we take the number 62 and subtract the mean from it, and then we divide by the standard deviation, which is 2.7. So if I just do this on my calculator, I get about negative 1.11. You'll actually get negative 1.111111. It gets repeating, but just remember, if we're doing z-scores, just round it to 2 decimal places. So we need the table value for this number, but first let's go ahead and draw our little diagram to make sure that we know what area we're supposed to be finding. So I have my mean of 0, and my z-score is negative 1.11, so I'm going to put that about right here. Okay, and I want to know the probability that a woman is 62 inches or shorter, but we just converted that to negative 1.11. So I want something that's negative 1.11 or less. So that's either here or it's going to be on the left-hand side, which is smaller than negative 1.11. But if you remember when we originally introduced z-scores, we said that when you go to that table and look for the z-score, it actually gives you that area. So it gives you the area to the left of the z-score, which is exactly what we want. So all we have to do is go to our table and find the value associated with the z-score of negative 1.11, because that automatically gives us the area to the left of that number. So let's go to our table and find the table value for z equals negative 1.11. Okay, so we want to come down to negative 1.1, which is right here. And then we want to see where it meets on the top row, 0.01, and they meet at 0.1335. So that is the number we were looking for. So our table value is 0. Sorry, my thing is having an issue. Okay, apparently I can't write. Okay. Okay, awesome. which is what a few of you said over chat. So great, you guys got the correct answer. Oh, man. My PDF thing over here is really struggling. Oh, there we go. Okay, let me save what I've written so far because my app seems to be on the struggle bus today. So let me just make sure that I at least get it saved. Okay. All right, so that's how we do the first one. Any questions on that one? All right, and then next we have one more example of a similar type of problem that we've done, but let's just do this one as well. So this is what is the probability that a college woman is between 63 and 69 inches tall. So we have two X values that we're concerned about right now. So we need to convert both of those to Z-scores, just like the first example that we did today. So let's start by doing that. So I'm going to convert 63 first. So my Z1, sorry, just checking the chat. My Z1 is 63, and I go ahead and subtract the mean from it, which is 65. So 63 minus 65 over a standard deviation of 2.7. I'm plugging that into my calculator. Gives me negative 0.74. Let's do the second one. So Z2. This time I'm interested in the number 69, and I'm going to subtract the mean from that and divide by my standard deviation. Just using my calculator again. This gives me a Z-score of 1.48. Okay, so now let's draw our little diagram again so we can see what area we're interested in. So I'll do that up here. So I have a mean of 0, and then I have one Z-score of 1.48, and I have another one of negative 0.74. And I'm looking for the area between these two because I want the probability that a woman lies between those two heights that I started with. So I'm looking for the area between these two, which looks like this. All right, so that means I need to go to my table and find the table value for both of these. Oh, good question. On quizzes or exams, do you want me to draw, or do I want you to draw that diagram? If I wanted you to draw it, I would definitely say it in the question. So if I wanted you to, I would say like, hey, find this probability and also draw the diagram for it. If it doesn't say to draw it, you definitely don't need to. It is helpful though, but if you can do it without drawing it, you don't have to. So unless I explicitly ask for the diagram, you don't need to. So like today on the quiz, if I ask you to compute the probability that Z is between certain values and you're good with just going to the chart and doing it, you don't have to draw anything for me. However, with that, I will say that it's fine if you can do some work in your head, but the more work that you put down, in case your answer is wrong, the more partial credit that I can give you. So like, let's say you got the final answer wrong and you didn't draw anything and didn't really put any work down. At least if you drew something, I could see, oh, hey, they knew what area they were looking for, and that would get you some partial credit. So it's never a bad idea to put your work down, but it's not required. Okay. I think we should all be pretty good at finding table values by now, so I'm just going to assume that we're okay with that and just write down what they are, because obviously I did this earlier, so I know what the table values are. So oh my gosh, my PDF thing is really struggling today, guys. Okay, so my table value for negative 0.74 is going to be 0.2296. And then my table value for 1.48 is going to be 0.9306. And I'm just going to take my table value for 1.48 and subtract from it the other value for negative 0.74. So I have 0.9306 minus 0.2296. Go ahead and do that math. That gives us 0.701. Okay, any questions on? Cool. Okay. So that is like the type of problems that we did last class period, but now they just have actual applications. So there were actual word problems to these and actual scenarios given. So now you know how to apply it. Hopefully, it seems like everyone was doing pretty okay with that. But if you're not and you're confused at all, please reach out, or ask questions. I'm happy to go over them again. But let's go ahead and jump into example 3, which is a little bit different. So example 3 says, what IQ score do you need to get into Mensa, a society of high IQ people whose members have a score on an IQ test at the 98th percentile or higher? So the mean IQ score is 100 with a standard deviation of 16. So a lot of the same information is given here. So right off the bat, we have the mean. Man, my little app is really having a hard time. Right, let's try a yellow highlighter. Okay, like that one. The mean IQ score is 100, and we're told that there's a standard deviation of 16. Okay, so that will be helpful. But instead we're going to ask a different question. So instead of being asked like, oh, what's the probability that a randomly selected person has an IQ score that falls within like these two scores, or it's less than this score, or it's more than this score. So instead of being asked that, we're actually asked something about the percentile, which is a different question, but we can find it using all the same information and like kind of the same process, just a little different, that we've been doing. So part A says, first determine what z-score is related to the 98th percentile. So let's talk about what the 98th percentile even means, because this isn't like vocabulary that we've really discussed before. So it says, to be in the 98th percentile means that 98% of IQ test takers scored at or below your score. So that is very similar verbiage to when we've drawn out that distribution and we've said, okay, this is the area that falls between these two lines, or this percent of people are between these two z-scores. So what we need to do is figure out what score is related to having 98% of the test takers being at or below your score. So when we look to the z-score chart that we use, it gives us the area, the area between that score all the way to the left, or this can also be got as like probability. So we kind of need to work backwards this time. So we need to see what z-score is related to a probability of 0.98. So right here it says again, i.e. 0.9800. So we're looking for the 98th percentile. So we're going to work backwards. We're going to look at that chart and see where 0.9800 is. So what z-score is associated with that? So let me pull up our little chart. Okay, so let's look at some of these numbers here. And instead of looking at the top row and the left column, this time I'm looking at the numbers in the center because I'm working backwards. So I want to find the probability or the percent or the area of 0.9800, and I want to see what z-score is associated there. However, I don't see anything even close to 0.9800 on this chart, so it must be on my other one with the positive numbers. Okay, now I can see I've got some higher ones here. So I'm looking for 0.9800. So let's zoom in here and try to find some. Okay, so I see something kind of close. I have 0.9803. But I also have 0.9798. So I actually don't have exactly 0.9800 anywhere. So that might be kind of confusing, and you might ask, okay, well, if that's not anywhere on the chart, what z-score am I supposed to use? So if you don't have the exact number that you're looking for, you're going to pick the number that's closest to the one that you're looking for. So I have 0.9803, which is 0.0003 away from what I'm looking for. But I also have 0.9798, which is only 0.0002 away from what I'm looking for. So this number is closer. This one is closer to, oh my goodness. Okay, that one's closer to 0.9800 out of the two. So yes, 0.9800 is somewhere between these two, but I'm going to pick the one that it's closer to, and I'm going to find the z-score associated with that. So that would be 2.05. So let's go ahead and write that down. Oh my goodness, I am so sorry. My laptop is really not having it today, apparently. Let's give this another try. If not, I'm gonna close. Okay, I'm gonna stop screen sharing, close the app out, and reopen it. So sorry, everyone. All right, let's try this again. Okay, so I found the z-score to be 2.05. So you can see we just worked backwards this time. So instead of giving us like what the area we wanted was, and we want to find, or sorry, instead of asking us to find the area or the probability, this time we were given that. So we wanted to find the z-score that was associated with an area of 0.9800, working back. So the next step says, what is the IQ for the 98th percentile? Okay, it says hint, use the z-score formula and solve for x. So it's truly working backwards because in the past we were given an x value and a mean and a standard deviation, and we converted that to a z-score. Well, this time we're doing the opposite, and we're starting with the area, and then we're finding the z-score, and now we're converting that to an x value. So we're going backwards. So remember when we first started doing this stuff, we had the formula z equals x minus mu over sigma. So we have three of these items. We have, sorry, I should have written z equals. We know that z is 2.05. We were also given the mean and we were given the standard deviation. So now we have to work backwards to solve for x. So this is where you have to bring in your algebra skills and go ahead and find what x is. So let's fill in everything we have. We know Z is 2.05. We want to find X, and we know that the mean is 100, and the standard deviation is 16. So in order to solve for X, if you can recall some of your algebra solving skills, we're going to multiply both sides by 16. So 2.05 times 16 gives me 32.8 is equal to X minus 100. And then to solve for X, we just need to add 100 to both sides. Great, so X is 132.8. I'm just going to round up to a whole number because we are looking for an IQ score. So I'm going to say our final answer is 133. So I just worked backwards, but if you don't want to have to worry about, solving for X and plugging everything in, we can just use this formula to derive a new one for if you're solving for X. So if I multiply both sides by sigma, this is Z times sigma equals X minus mu. So if I want to solve for X, that means that X is equal to Z times sigma plus mu. So if you're ever wanting to find what X is, this is your formula to use. So if you have all the other information, you just take and multiply your Z-score times sigma, and then you go ahead and add mu to it. So what does this tell you? This tells you that for the 98th percentile, you need to have an IQ score of 133. So instead, we worked backwards this time. Same kind of process, just literally backwards. And by the language that is used in the question, you should be able to decipher between a question that needs you to work the traditional way or work backwards. I will try to make that extremely clear on any form of an exam or quiz. Okay, any questions before we do our last topic for today? Awesome. Okay, so to wrap up section 6.2, we're talking a little bit more about normality. So we've talked about the normal distribution, the standard normal distribution, and we've talked about some characteristics of them. So we're going to wrap this up right now. So determining normality. So the easiest way to determine if a distribution is bell-shaped is to draw a histogram for the data. So we talked about this like maybe 2 weeks ago where we said, oh, if you draw a histogram and it has that bell shape, you can say, oh, hey, maybe that's normal. So we're just bringing that up again. If the histogram is not approximately bell-shaped, then the distribution is not normally distributed. So if you ever draw a histogram and you don't get a bell shape, you know it's not normal. But on top of that, we have the skewness of a data set can be checked by using the Pearson's index PI of skewness. Interestingly enough, I have this typed out on the lecture notes, and for some reason, it did not translate onto the copy with the black background. So in my copy, it's typed on, like in my white background, black text copy, it's typed on here, but for some reason, it did not stick on this one. So I'm gonna just write it in, because I'm just noticing that it's missing. So write this in on your lecture notes, depending on which one you're using. But the Pearson's index, PI, is equal to 3 times X bar minus the median all over S. And remember that X bar is the mean and that S is the standard deviation. Okay, so we can check the skewness of a data set by using this formula if we know the median, the mean, and the standard deviation. And so we have down here, if the index is greater than or equal to 1, so if it's greater than or equal to 1, or less than or equal to -1, it can be concluded that the data is significantly skewed. So this is a concrete formula to check if the data is significantly skewed or not. So instead of maybe just looking at something and having to interpret it and saying, oh, I'm guessing this is skewed, we now kind of have a formula to help us determine that. Also, it says the data should be checked for outliers since they can have a big effect on normality. So that's another thing to consider. And remember, we check for outliers using that 1.5 times the interquartile range criteria. So down here, finally, we get, if the histogram is bell-shaped, the PI is between -1 and +1, and there are no outliers, then we can conclude that a distribution is normally distributed. Which, like we've mentioned, that's really something that we value is when it's normally distributed because there's a lot of nice properties that go along with it. So we have three things. If it's bell-shaped, if the PI is between -1 and +1, and there are no outliers, then we can say, hey, this is normal. So let's just wrap this up by doing an example of finding the PI. So consider the data set with a mean of 126.5, a median of 144, and a standard deviation of 38.65. So let's find the PI and interpret it. So let me scroll up so you can see the formula. The formula is given as 3 times the mean minus the median. So we have 3 times, our mean is 126.5, and our median is 144. And then we divide by the standard deviation. Okay, so let's just plug this into our calculator and see what we get. Okay, and I got a value of -1.36. Okay, well, up above, we saw that if the index is greater than or equal to 1 or less than or equal to -1, then we can conclude the data is significantly skewed. Well, -1.36 is definitely less than 1, so we can say that our data is significantly skewed. Okay, that is the last thing in this section. So just to wrap it up, we just did some examples of using the standard normal distribution and then talked about some criteria for checking to see if something indeed is normal. And that's going to complete section 6.2. If it is left or right skewed. So I'm not sure if the book like says that this tells you if it's left or right skewed. That's a good question. Let me look into that because that's a really good question. I just know that they guarantee that it's significantly skewed, but let me see if I can find the answer. Okay, there actually is an answer. So if the index is, oh, wait, that probably makes sense. Okay, no, I got it. So if it's if it's less than -1, I believe it's skewed to the left, and if it's greater than 1, then it's skewed to the right. Let me double check that in the textbook, but I think that's correct. Okay, yes, that's true. So let me write that down because that's a great thing to know. So if the PI is greater than or equal to +1, then I thought it said in the textbook. I don't think it does. Okay, so actually, you probably won't be required to know this, but I'm gonna write it down anyways. I probably would never ask you on a test, but I'll write it down just for the sake of knowing it. So, um, then it's skewed right. If pi is less than or equal to -1, then it is skewed to the left. Let me double check that that's a less than or equal to, just to make sure. Yes, okay, that's correct. So if it's greater than or equal to +1, it's skewed to the right. And if it's less than or equal to -1, then it's skewed to the left. Okay, yes. So that is a good question to ask. So there you are. I don't know that I would ever ask you it, but great question. So good to know. Okay, any other questions before we stop for today? Okay, awesome. So I'm going to stop sharing my screen. We'll end the recording.